Hello guys, welcome back to my channel. So like I said, I'll be dropping a full video for the integral of square root of 4x squared plus 1 dx. So when you want to solve this kind of question, you have to, there are some things you need to know under this, but I wouldn't want to make the video too long, but then I'll make sure you understand. You first let x equals 1 over 2 hyperbolic sine u. Now there are different, if you have negative here, there are ways of doing it. So in the next video I'll also tell you why we are using this. So for now, you have x equals 1 over 2 hyperbolic sine u. So when you differentiate x, if I differentiate sine, hyperbolic sine, it will give me hyperbolic cos. So dx du equals 1 over 2 hyperbolic cos u. Now from here, u equals cross multiply, I have 2x, but if I divide both sides by hyperbolic sine, I have sine inverse of 2x. So u equals hyperbolic sine inverse of 2x. Now I just go back to the integral and then impute x anywhere I see it. I put x equals 1 over 2 hyperbolic sine u. So I have my integral to be equal to square root of 4. Now x, instead of writing x, I'll use 1 over 2 hyperbolic sine u. So I have 1 over 2 hyperbolic sine u, but don't forget the x has a square on it, so I'm going to have to square this. So I have 1 over 2 hyperbolic sine u all squared plus 1. Yeah, now what's your dx? Here, from here, if you cross multiply, you have dx equals 1 over 2 hyperbolic cos u, then du. So I'll have 1 over 2 hyperbolic cos u du. Now if I square 1 over 2, I have 1 over 4. Then I square hyperbolic sine u, I have hyperbolic sine squared u. So automatically this 4 will cancel the 4 here. Then I have hyperbolic sine squared u plus the 1 here initially multiplied by 1 over 2 hyperbolic cos u du. Then since I've done that, I just have, since this 4 will cancel this 4, I have hyperbolic sine squared u plus 1. Don't forget this square root is not, this dx is not inside the square root. So I have 1 over 2 hyperbolic cos u du. Now you have to recall that hyperbolic, this is it actually, hyperbolic cos squared u minus hyperbolic sine squared u equals 1. So it implies when you have this, hyperbolic cos squared u will be equal to hyperbolic sine squared u plus 1. It is different from the normal, initially the normal this thing, you have cos squared x plus sine squared x equals 1, but here negative, the difference is equal to 1. Then afterwards, instead of having hyperbolic sine squared u plus 1, I won't use hyperbolic sine squared u plus 1 again, because I want everything to be in terms of hyperbolic cos, so I'll be able to integrate in a better way. So I just impute hyperbolic cos squared u multiplied by the same thing here, 1 over 2 hyperbolic cos u du. Now if I have square root of 2 squared, this square will cancel the square root, so I'll be left with what? 2. See the same thing as, 2 squared is 4, square root of 4 is what? 2. So anything that has squared will cancel square root, because square root is actually half. So this is the same thing as 2 raised to power 2 multiplied by half. So half, so we'll be left with what? 2. So the same thing here, I'll be left with just hyperbolic cos u multiplied by 1 over 2 hyperbolic cos u du. So if I multiply these two, I have this 1 over 2 will come out. Then I have hyperbolic cos squared u du. You also need to recall you need to recall that hyperbolic cos squared u equals 1 over 2, because I can't integrate like this. I need to break down. So after breaking down, hyperbolic cos squared u equals 1 over 2, 1 plus hyperbolic cos 2u. So you need to take note of this. Take note of this. This is important. Also, take note of something else. I'm supposed to give you this in the beginning of the video. Sorry. So hyperbolic sine 2u is equal to 2 hyperbolic sine u hyperbolic cos u. So this is important also. You can just keep it somewhere, so you know that I'm going to use it later on. Hyperbolic sine 2u equals 2 hyperbolic sine u hyperbolic cos u. So on to the next. So now, instead of rewriting hyperbolic cos squared u, because I can't integrate this way, I told you I have to expand. So after expanding, I just come here. Don't forget I still have my half initially. Then I have to put this in a bracket so that I won't have problem when I'm solving. So I have 1 over 2, because this is the same thing as 1 over 2 plus 1 over 2 hyperbolic cos 2u. So I have 1 over 2 plus 1 over 2 hyperbolic cos 2u du. Now I use 1 over 2 to open the bracket. I have 1 over 4 plus 1 over 4 hyperbolic cos 2u du. Now 1 over 4 is common, right? So I can factorize. I bring out 1 over 4. So I have 1 plus hyperbolic cos 2u du. Now, if I'm to integrate this, if I integrate 1, I'll have what? U. If I'm to integrate cos 2u, it means I differentiate what is in front first. So when I differentiate what is in the front first, I differentiate 2u, I'll have what? 2. So I take inverse of 2. So that's 1 over 2. Then if I integrate hyperbolic cos, I should have hyperbolic sine. So then I have to write hyperbolic sine 2u. So this is just the way it goes. If I want to integrate hyperbolic cos 2u, don't forget, all you just do is differentiate what you have in front. If I differentiate what I have in front, if I differentiate 2u, I have 2. So I take the inverse, so 1 over 2. Differentiate hyperbolic cos, you have hyperbolic sine. Then we write the value back. So if I have, let's say I have hyperbolic cos 2u squared. So what I'll just do is I differentiate this front. So if I differentiate this, I should have 4u, right? So I take the inverse, so it should be 1 over 4u. Integrate this, I have hyperbolic sine. Then I write the question back, 2u squared. I hope you get it. So here, that's why I have this. Then I open the bracket. So after opening the bracket, I'm looking for something else, not this. So I told you that I should keep something the other time, which is hyperbolic sine 2u equals 2 hyperbolic sine u, should be sine u, then cos hyperbolic cos u. Then instead of writing hyperbolic sine 2u, I'll write this back. So I'll now have 1 over 4u plus 1 over 8, 2 hyperbolic sine u hyperbolic cos u. Now this 2 cancel this, so I have 1 over 4 left. So here I have 1 over 4u, then 1 over 4 hyperbolic sine u cos u. Now I should be getting my answer in terms of x and not u. You know, initially recall that I said your u equals sine inverse of 2x. So that means anywhere I see u, I impute it as hyperbolic sine inverse of 2x. So that is why here I'm having, instead of u, I have 1 over 4 hyperbolic sine inverse of 2x plus 1 over 4. This is hyperbolic sine. Then what is my u? Sine inverse is, now if I have If I have 2 raised to power minus 1, the same thing as what? 1 over 2. So if I have a parabolic sine inverse, it means 1 over a parabolic sine. So that's why I have it here to be a parabolic sine multiplied by 1 over parabolic sine 2x. So this we cancel this will cancel this, so I'll be left with 2x over 4, and 2 here 1, 2 here 2, so I have x over 2. Then your cos u is square root of 4x squared plus 1. So I can tell you that the integral of 4x squared plus 1 is equivalent to 1 over 4 parabolic sine inverse of 2x plus x over 2 square root of 4x squared plus 1. So that is how we did the other integral when we were trying to prove a question under functions, I guess. So that is how we got this integral. So you don't have to memorize, as I always say. Okay, if you recall watching this video, this is what you're going to get. So you put in your boundaries and then you get this, which has proven that I of x squared equals this. So I hope you enjoyed the video. Do subscribe, and then if you have any question, you can drop it in the comment box, as we'll do well to reply everything. And have a nice day. Thank you.